Here are solutions to homework set number 8 for ECE 111, Intro to ECE. This homework set looks at problems you'll encounter when you take Circuits 1. So Circuits 1 is a fun course. It's where you finally start taking courses in your major. It looks at DC and AC analysis of primarily resistor circuits. Towards the end, we start adding capacitors and inductors. For resistor circuits, the basic equations are V equals IR and power is volts times amps. So with those equations, given two terms, you can find all the rest. So for example, if I have 12 volts and 1.7 amps, what that means is if I take voltage divided by current, I get resistance. You've got 7.05 ohms. Voltage times amps is power. It's producing 20 watts. It's 12 volts and 24 ohms. Volts divided by ohms gives you current, 2 amps. Volts times amps gives you power, 24 watts. If I have 1.7 amps at 50 watts, watts divided by amps gives you volts, 29 volts. 29 volts over 1.7 amps is 17 ohms. And 12 volts, 4 watts, power over volts gives you amps, 0.33 amps. Volts over amps gives you ohms, 36 ohms. Problem 2 is reading resistors. Resistors are specified by color code. If you look at them, you can tell what they are. It's how they're labeled. What the numbers mean is 0 through 9 corresponds to colors. The first two numbers is the mantissa. The second number is, or third number is the exponent. So this would be 5, 6, 1. What that means is 56 times 10 to the 1 ohms, or 560 ohms. Gray, red, black is 8, 2, 0. 82 times 10 to the 0, 82 ohms. And yellow, orange, red, yellow is 4, 3, 2. That's 43 times 10 to the 2 ohms, 4.3K. So just by looking at the colors, I can tell you what the resistor is. That's kind of important because in the labs, usually there's a big bin full of resistors. You're supposed to put them back in the bin. No one does. So if you're looking for a resistor, just kind of go scrounging through the resistors to find the right value. There's lots of them, but fortunately we only use half dozen different types of resistors in labs. So it's pretty easy finding the one you want. Problem 3 looks at Kirchhoff's law. Kirchhoff's law for conservation of voltage says that if I take a voltmeter, short the leads, I get 0 volts. If I go around to any closed path, wind up back where I started, the total has to be 0. So the trick here is find a path where there's only one unknown, for example, the pink one. This says if I hit the minus sign first, I'll subtract, plus sign first, I'll add. Minus 100 plus D plus 80 equals 0. One equation, one unknown, solve for D. D is 20 volts. Once I know D, I can go around this path. Minus 80 plus E plus 75 equals 0. E is 5 volts. Going around this path. Minus D minus 50 plus A plus 55 equals 0. Solve for A. A is 15 volts. So on and so on. And this is what you should get. That's conservation of voltage. Conservation of current says that at any given node, current in equals current out. So like at this point, I have 100 amps going in. I have to have 100 amps going out. So if 15 go right, that means A must be 85. At this point, current in equals current out. I've got 85 in, 85 out. That works. At this node, current in equals current out, 85 in. These two have to add up to 85. B must be 12. So keep on going, and these would be the unknown currents. Problem 5 looks at adding resistors in series and parallel. So when you're in series, that looks like this. All the current through the first resistor has to go through the second resistor. That's in series. In parallel, the voltage on one side is equal to the voltage on, or both resistors have the same voltage on one side and the other. That's parallel. In series, they add. In parallel, it's the sum of the inverses inverted. So I've got to look at the circuit and try to figure out what's in series, what's in parallel. The 400 and 600 are in parallel. So adding them as the sum of the inverses inverted, this is 240 ohms. That is in series with 300. In series they add, so together that gives you 540 ohms. That 540 is in parallel with 700. Adding them in parallel gives you 304 ohms, so all this together is 304. In series with 200 gives you 504. In parallel with 500 gives you 251. In series with 100 gives you 351. So there's the answer. You can do this in Matlab. This is typically what you'll see on one of the tests in electronics, or in circuits 1. You need a calculator that can do this. One calculator I highly recommend is the Sp25 or RPN calculators. With an RPN calculator, it's actually pretty easy, pretty straightforward. To give an idea of how quick and easy they are, I've got 400 in parallel with 600. I would take 400, take the inverse, 600, take the inverse, add inverse, 240 ohms. In series with 300, add 540 ohms. In parallel with 700, take the inverse, 700, inverse, add inverse, 304 ohms. Add 200, 504 ohms. In parallel with 500, 251 ohms plus 100, 351 ohms. Done. On to the next test problem. I can check my answers in Circuit Lab. There is a thing called Chegg. Chegg is a way that you can submit homework problems and somebody else will solve them for you. We faculty hate Chegg. You don't need Chegg. It costs like $50 a year. You don't need it. Just take the circuit, build it in Circuit Lab. To find the resistance, I'll apply a test voltage, apply 10 volts to it, find out what the current is at this point, tell it to solve, and tells me at 10 volts it is drawing 28 milliamps. From V equals IR, I know the resistance of all this is 10 volts over 28 milliamps, 351 ohms. Same answer. So when you take circuits 1, you don't really need Chegg. Just take your circuits, throw it on Circuit Lab, and check. If your calculations are correct, they'll match up with the Circuit Lab. If they're incorrect, either Circuit Lab is wrong or you're wrong. My money's on Circuit Lab. Problem 7 is repeat for another circuit. I can do that in Matlab. 100 plus 40 is 140. In parallel with 200 is 82 ohms. So there's 82. In series with 30 is 112 ohms. In parallel with 300 is 81 ohms. In series with 20 is 101 ohms. So there's the total resistance. Again, with an HP calculator, I can do that. I've got 100 in series with 40 is 140. I can do that in my head. In parallel with 200, take the inverse, 200, inverse, add inverse, 82 ohms. In series with 30, 112. In parallel with 300, inverse, 300, inverse, plus inverse, 81 ohms. In series with 20, 101 ohms. And Circuit Lab again. Build the circuit, apply test voltage. We have 10 volts. The current coming in is 98 milliamps. The resistance then is 10 volts over 98 milliamps, 101 ohms. Same answer. Last problem is voltage division. If I build this circuit, I'm going to get a voltage at V1, V2, V3. One way to find them is voltage division. With voltage division, V3 is 100, what I'm measuring over the total, 100 plus 40. That percentage of V2. V2 is this resistance, the resistance looking right, that's that whole mess, is R2 over R2 plus 30. That percentage of V1. And then V1 is this whole mess, R1, over R1 plus 20, the percentage of B0. I know B0, so with that I can find B1, with that I can find B2, with that find B3. The first step then is to have to find the resistances looking right at each of these points. This is 300 ohms, 82 ohms, 81 ohms. We did that in the last problem. By voltage division then, I know that V1 is this percentage of V0, 8 volts. V2 is that percentage of V1, 5.88 volts. V3 is that percentage of V2, 4.2 volts. As a check, I don't need to submit on Chegg. I can just throw it in Circuit Lab, build the circuit in C, and I get the same answer. So that's homework set number 8 in 111. This is a set you don't really need Matlab. I'm solving one equation, one unknown. Matlab does work, but it's kind of an overkill. Where Matlab really shines is next week's homework, when I'm trying to solve 3 equations, 3 unknowns. That's when you really need Matlab. But this is homework set number 8 for ECE 111.